Hello everyone and welcome back. In today's lecture, we continue our discussion of the theory of the firm by focusing on production and cost in the short run. This lecture is very important because it connects how firms produce output with how costs behave. In the short run, we assume that some inputs are fixed and others are variable. Typically, capital such as machinery or buildings is fixed, while labor is variable. Because capital does not change in the short run, output depends only on labor. So we can write the production function as the output being a function of labor. We denote output as Q, which is also called total product or TP. This means that as we change the amount of labor, total output changes accordingly. Let's look at an example. Suppose we are measuring how many trees can be cut down per day depending on the number of lumberjacks. With one worker, the output is 4 trees. With two workers, output increases to 10 trees. With three workers, output is 12, and with four workers, output is 13. When a fifth worker is added, output remains at 13. This shows that adding more workers increases output, but not always at the same rate. Now we introduce an important concept called marginal product. Marginal product is the additional output produced by adding one more worker. It tells us how much extra output we gain when labor increases by 1 unit. Let's calculate marginal product using the lumberjack example. When you go from 0 workers to 1 worker, output increases from 0 to 4, so the marginal product is 4. When we go from 1 to 2 workers, output increases from 4 to 10, so the marginal product is 6. From 2 to 3 workers, output increases from 10 to 12, so the marginal product is 2. From 3 to 4 workers, output increases from 12 to 13, so the marginal product is 1. Finally, from 4 to 5 workers, output does not increase, so the marginal product is 0. From these calculations, we can see an important pattern. At first, adding workers increases marginal product, but after a certain point, marginal product begins to decline. This is known as the law of the diminishing marginal productivity, which states that as more labor is added, the additional output produced by each new workers eventually decreases. This happens because fixed inputs such as land or equipment become crowded, making additional workers less productive. When we graph total product, we see that output increases as more workers are added up to a certain point. When you graph marginal product, we see that it initially rises and then begins to fall. This reflects the pattern we observed in the table. In general, total product increases at an increasing rate at first, then at a decreasing rate. Marginal product rises initially, reaches at a peak, and then declines. These patterns are very common in production process. Now let's connect production to cost. A firm's total cost depends on how many inputs it uses and the prices of those inputs. Firms must pay for factors of production such as raw materials, rent, wages, and financial capital. These payments are called factor payments, and they determine the firm's cost structure. In the short run, we divided costs into two types. Fixed costs are costs that do not change with the level of output. Examples include rent or equipment costs. Variable costs are costs that change with productions, such as wages for labor. Total cost is the sum of the fixed cost and variable cost. Since labor is the only variable input in the short run, total cost mainly depends on wages. Let's look at a simple example. As the number of widgets produced increases, total cost also increases. However, firms do not only focus on total cost. They also care about cost per unit, which leads us to average and marginal cost concepts. Now we define three important cost measures. Average total cost, or ATC, is total cost divided by the quantity of output. This tells us the cost per unit. Marginal cost, or MC, is the additional cost of producing one more unit of output. Average variable cost, or AVC, is variable cost divided by output. These measures help firms make production decisions. Let's examine a detailed example. We are given data on labor, output, fixed cost, and variable cost. Fixed cost remains constant at $160 regardless of output. Variable cost increases as more labor is used. Total cost calculated by adding fixed cost and variable cost. Now let's calculate average total cost. We use the formula average total cost equals total cost divided by quantity. For example, when output is 16 units and total cost is $240, average total cost is 240 divided by 16, which equals $15. As output increases, average total cost decreases at first, because fixed costs are spread over more units. Eventually, average total cost begins to rise due to increasing variable cost and diminishing returns. Now let's calculate marginal cost. Marginal cost is the change in total cost divided by the change in quantity. For example, when output increases from 16 to 40, total cost increases from 240 to 320. The change in cost is 80 and the change in quantity is 24. So marginal cost is about 3.3, 3.33. As output increases further, marginal cost rises due to diminishing marginal productivity. Now let's calculate average variable cost. Average variable cost equals variable cost divided by quantity. For example, when variable cost is 80 and output is 16, average variable cost is 5. As output increases, average variable cost initially decreases but eventually rises. We also observe that the average variable cost is always below average total cost because total cost includes fixed cost. Finally, let's summarize the shape of the cost curves. Average total cost is typically U-shaped. Average variable cost is also usually U-shaped and lies below the average total cost curve. Marginal cost is generally upward sloping. The upward slope of marginal cost reflects diminishing marginal productivity, meaning additional units become more expensive to produce. Thank you for watching.